This video is going to go over some common vocab words that we can use to categorize or classify numbers. So we're kind of looking at characteristics that certain groups of numbers have in common. The first vocab word I have over here is whole numbers, and that is a word that you guys have undoubtedly heard of before. A whole number, though, is going to be basically 0 and the counting numbers. So counting numbers being 1, 2, 3, 4, and so on. So we got 0, 1, 2, 3, and so on. When you're talking about a whole number, there are no decimals allowed, other than 0.0, and no negatives. So those are two things to keep in mind when you're talking about a whole number. And over on the left side of the page right here, I'm going to make kind of a chart or graph, a picture that'll help you guys keep straight what's going on here. So in the middle of my picture, I'm going to make a little box for whole numbers. And I'm going to put a few examples of whole numbers in here. So I could have 0, maybe 72, 108. Just put a few examples of whole numbers in that box. And my next vocab word on here is an integer. This is a vocab word you'll use a lot in math, and it's a word that people forget a lot too. So definitely a word right here I would make sure you make note of, and that you do your best to memorize what an integer is, because it comes up a lot. An integer, all it is a positive or negative whole number. So it's all the whole numbers and the negative whole numbers. And negative whole numbers. When you're talking about an integer, there's still no decimals allowed, but now negatives are okay. And I'm going to go ahead on my picture right here and draw a bigger box surrounding the whole numbers. So draw a box maybe like this, and I'll label that box integers. So notice that all of the whole number box right here is inside of my integer box as well. That's because all whole numbers are still integers. So if I look at like my 72 right here, it's in the whole number box. It's also inside of the integer box too. The thing I'm going to put in the outside of my integer circle, my integer box right here, are numbers that are integers but not whole numbers. So that basically would be my negatives. I'll put like a -3, -14. Just get a couple examples down right there. My next vocab word on my list is called a rational number. And a rational number, there are two ways of thinking about it. The first, and that the one that I think kids usually tend to do better with overall. When you're dealing with rational numbers, decimals are okay, but they have to stop or repeat. So, as an example, if I was doing 4.3 repeating, that decimal is going to go on forever, 0.33333, but it repeats. There's a pattern to it. If I had 2.616161 and it kept on going like that, that would be a rational number because it repeats. Numbers that are not rational numbers would be things like if you have pi. If you guys remember pi from geometry, pi is not a rational number because it goes on forever. It's 3.14159, and it just keeps on going without repeating. The other common type of rational number that's not rational you'll come across are square roots. If you do like the square root of a number that's not a perfect square, maybe like the square root of 5, that decimal is going to go on forever, and it's not going to repeat. So I'm going to write in my red part right here, things that are not rational numbers are decimals. No, no decimals that go forever without repeating. And like I said, typically you'll see square roots, and pi is the other big example of an irrational number, which I'll get to in a minute. Another common way, which I'll get into more later in the year, you'll see it come up in later chapters, the word rational typically implies a fraction. a rational number, another way of defining it instead of this decimal thing, you can also say that a rational number is a number that you can write as a fraction with integers in the top and bottom. If that's helpful to think about it like that, again, rational number is a fraction with integers on top and bottom. So if I can do like negative 14 over 5, that decimal is either going to repeat or it's going to stop. That's kind of an extra piece of info for right now. But on my picture here, I'm going to go ahead and I am going to draw an even bigger box here surrounding my previous example. And what I'm going to do here is actually I'm going to cut off my box. I'm going to make it so this whole, from this blue line up, is my new box. That's going to be rational numbers. So whole numbers are rational numbers. 72 as a decimal is 72.0. That decimal stops. If I do negative 3, negative 3.0, the decimal stops. So all these things in here are still going to be rational numbers. But the things that are going to go in this outside box would be other decimals, like 0.38, that's not an integer or a whole number. Fractions, negative 15 over 7, and stuff like that. If I do like the square root of, let's go with the square root of 16, that's equal to 4, so that's a rational, I guess that one technically wouldn't fit in here. Because you could put that in an earlier box. Let me do the square root of 0.25. The square root of 0.25, if you type in your calculator, is going to be 0.5, which is a rational number. So, next on our list here is an irrational number. An irrational number looks a lot like a rational number. They're almost the same word. Irrational numbers are real numbers that are not rational. So with irrational numbers, your decimal goes on forever without repeating. And typically, like I said earlier, I kind of alluded to this anyway, the most common type of irrational number we're going to come across in our class are square roots. So I'm going to make this bottom part of my box right here irrational numbers. So notice that the irrationals, like this whole bottom box right here, these things up top are not irrational numbers. Irrational numbers are going to be things like square root of 7 and pi and the square root of 92. Numbers that are not, they're going to go on forever, they're not going to repeat. My final vocab word here is a real number. A real number, basically any number you've dealt with at this point in your math careers is a real number. It's like every number you could possibly think of out there. So real numbers, it's not a very official definition, but it's helpful, I think, for right now. If you can get an answer when you type it in the calculator, it's a real number. So if you can get an answer on the calculator, it's real. It's a real number. Another way of thinking about it, which maybe is a little better, you can write it as a decimal. Like you can get a decimal with it, whether the decimal goes on forever or anything like that. So my whole box right here, this whole left side of my picture, my irrational, rational, this entire picture, I'm going to write it off on the side here. You guys can make just a giant box around it if you want. Everything on this left side of the paper are real numbers. So basically, like I said, every number you've thought of. I want to give one counter example so you know what isn't a real number. If I were to do on my calculator here, the square root of negative 5, and I try typing that in my calculator, it's going to say error, and it even says on here, non-real answer. So the answer is not a real number. That's the most common type you can see right now. So I'll go ahead and write that on here just so you guys have it. No square roots of negatives. And those are our basic vocab terms. On the next video, I'm going to show you guys how you can apply that to problems and classify numbers.